Okay, we good?
I don't fucking hear. Do you want to try to unmute your microphone, David?
Oh, visually, they see with no audio.
Yeah.
Can you hear me?
Perfect. Okay. I think we're good. So,
All right, cool. Well, thank you everybody for coming to another OWASP Toronto chapter meetup. We have two exciting presentations for you today. One from David, the other from Helen. But before we
Kotlin that is based on Java. It's very similar, but it's a little bit more modernized. It's not just for Android, but it's a very popular language that is used on Android. There's also this Smalley code, which is a low-level assembly code of capabilities. In JADX, it allows you to decompile the code and browse through that, as well as a lot of search capabilities. The APK tool is what you would use to generate the. There's a lot of things that you can do with it. So just generally to get started, those are kind of some of the tools that you would use for Android. And then the other tool that generally you would use is ADB. That's Android Debug Bridge, and this is the kind of the way you would communicate with a physical device. And so a lot of the commands where you're going to be doing pen testing, you're going to be running commands on the device, and ADB is what you would use to do that. Pushing and pulling files from the device, interacting with the system, setting up global proxies on the device, all kinds of things you can do through ADB. That's a little bit about Android. Now we're going to talk about iOS. It's similar. Instead of an APK file, it's going to be an IPA file. This is another compressed file. It's a zip. You just use the unzip tool and extract it, and you can look at the package. And so inside of that, you're going to see a number of things. You're going to see a payload directory right here that is going to be like the main thing inside of the application, inside of the file being unzipped. You're also going to have a number of other things that you're going to look for. There are plist files. There's kind of a main info.plist file that's going to show a lot of the configurations of the app. There are, depending on how the app was created, if it was originally intended for the App Store or if it was created from different ways of exporting the app, there might be a provisioning profile. So you might have, like for an ad hoc deployment, you might have certain device identifiers that the app is provisioned for, and there might be some more information in there that you can find, like how long it's provisioned for, things like that, as well as debug symbols and additional kind of files to look at. In terms of development, you're generally going to see Swift. Another that you might see is Objective-C. It's not quite like in Android, where Kotlin's kind of the way everything's moving. So it's Objective-C is still used in a lot of iOS apps, even sophisticated apps. So it's something that you might see when you're doing pen testing. In terms of tools, I already talked about the unzip command. When you are trying to communicate with the device, instead of ADB, that's an Android-specific thing. On iOS, generally, you're going to be using SSH. If you have a jailbroken device, you're going to be SSHing in with root access, and then you can kind of take it from there. In iOS, based on the way that the apps are generated, you can't decompile. You can only disassemble, where you it's going to be a lot more difficult to reverse engineer because you don't actually convert it back into a human readable type code. So you're going to be more looking at an assembly level code. And so it can add a lot more complexity in terms of understanding how the app was built in terms of reverse engineering it. And in addition to the complexity there, just generally with iOS in terms of finding a vulnerability and creating an exploit for it is going to be a lot more challenging in general. So in terms of data, now we're going to move kind of on to the next section. We're going to talk about data at rest. This means data that lives on your local phone, as opposed to data in transit where it's being sent over the internet with like HTTP. So first we're going to talk about iOS data at rest. There are kind of 5 main areas that you're going to be looking at for where the apps are storing data. We're going to go through those one at a time. But the first one is the keychain. You might be aware of that. That's designed to store sensitive information. There is also some other areas like the NS user defaults. These are generally for system defaults. It's not really designed to store sensitive information like a password or anything. So these are more like what's your locale and preferred language and things like that, kind of preferences depending on the app. We do see apps that are using that area to store sensitive information, so it's a good place to look. It's good. It would be an easy thing to find if that's where they're storing anything sensitive. There are also application databases. We're going to get into that as well. As I'm sure you all are aware, a lot of apps have a database that lives on the phone that's kind of part of the sandbox for the app. And there are plist files. I was talking about that earlier. There's kind of a main plist file and then additional plist files for maybe if you pull in additional third-party components and things like that. And the last place to look is in the debug logs. So we're going to get to this in a second, but there are times when applications are outputting things to the debug that they shouldn't be, that are considered sensitive. So talking about the keychain storage, this is where sensitive information should go, but you need a properly configured setting for each keychain item. This is going to be defining when is that sensitive information available, and so you can have it set that it's available anytime the phone is unlocked, for example, or you can. There's kind of a number of different how locked down it is, and the downside of that is convenience. And so the most secure thing that you can do is require biometrics every time to access that piece of information. But that can be inconvenient for the end user to continually have to either do a thumbprint or a Face ID. And so sometimes with applications with certain design decisions, they might actually have an insecure way of storing, an insecure implementation of how they're storing the information in the keychain. How can you access the keychain? You can, there are a number of ways of doing it. The way what I generally do is use Objection. This is a runtime framework that's built on top of something called Frida. Anything you can do in Objection, you should be able to do in Frida as well. And so, but Objection just makes it a little bit easier. So that's generally my go-to for dumping the keychain for an application. I was just already talking about Objection. This is a kind of a general tool that's going to allow you to do a lot of things. One of them is dumping the keychain. There's also additional things you can do like root detection, bypass, and SSL pinning. We can talk about that in a little bit more in the future. User defaults, I was mentioning, these are kind of not really made for a secure area for storing information. These are user preferences and things like that. What unit of measurement you have, or what temperature scale you're using, things like that. So It's another place to look for the insecure storage of data at rest. Another area to look for are the databases. And so if you can install an app and then you use the application and actually put sensitive information into the database and then try to pull that off of the device and look into how is the application built. Because again, we're doing black box testing here. So how is the application actually storing this information? And is there anything you can do to exploit that? Databases are generally going to be in a couple different languages, SQLite, Realm, or core data. And one of the benefits, this is again not a sales pitch, but one of the benefits is Corellium is make it easy to pull these databases because we give you root access. So if you have root access to a device, like jailbroken on iOS or rooted on Android, in theory, the application wouldn't know that the device is rooted, and then you can use the application the way it was designed to, and then you can pull these databases off for inspection. Once you identify the path to the directory, you can look for the databases. So in iOS, there is a certain path. Right here, this ID is a random unique identifier. And so sometimes it's a little bit of trial and error because depending on how many apps you have installed. But I usually look at the date that it was modified, which would line up with the date the app was installed. Once you find the directory for the app, then it's pretty easy to pull the database. So, or an objection. This is that tool. If you just hook into the app and just run env, it'll give you that ID. So that's another way to save time. The plist files are regarding configuration. Sometimes we see if they're used, it can be used to store data. Sometimes we see insecure uses of plist files to store like API tokens. This might happen if they're in a rush in the development and in the testing side, the QA side, and they don't pull it out when they're doing fraud. So you can also look for usernames, passwords, anything else. That's going to be once you get into the application directory, you go into the documents. One thing, there's just a lot of information on this stuff, so we're going to make the slides available after this, especially for the CTF. I want you all to be able to reference this information because it's so if you feel like I'm just throwing a lot of information out, it's because there's kind of a lot to cover. The last area for data arrest for iOS is in the debug logs. This is something that you can look at a number of different ways. If you use the Xcode simulator, that has something that gives you the ability. If you are connected into the device directly, you can use log. That's going to spit out a lot of information, but you can use log along with like grep for certain things that might be like searching only for things related to this app. And there's also there's a lot to talk about with debug logs, but in general, that's kind of the 101 of it. Android, kind of similar. They don't have the concept of a keychain in Android, and so you might see some parallels here, like the shared preferences is going to be information that is Booleans, floats, and things like that. These are shared preferences, like again, things that are not made to store secure information. What could you look for here are potentially API keys, user information, things like that. So this would be not where you should necessarily store sensitive information in Android. There's also in Android, even if there's the concept of an SD card in Android, even if your phone doesn't have a physical SD, it's like a virtual area of the internal storage. And This is an interesting area because information written here is going to persist after the app is uninstalled. It's not automatically removed like in the database directory, which I'm going to get to, though it has a clock. So sometimes we will see developers storing it here insecurely. In terms of databases, SQLite, Realm, and Firebase are the most common database languages that you're going to see. They're stored in a certain directory. It's data, and then the package name, and then databases. And similar to iOS, if you can find these databases and extract them, a lot of time you'll find that they're unencrypted. If they are encrypted, there are ways to do it properly, but what we've seen before is that they just store the decryption key as well. And so if you look, you might find a decryption key that will give you access to the information on the database. So just because it's encrypted, that doesn't mean that that's kind of the end of the search. So anything, yeah, it's the concept of security by obscurity. No one would guess that I would store the decryption key right here, and then eventually, given enough time, if someone's inclined enough, they're going to find it. So debug logs as well. There is a logcat binary that you can use that's a little bit easier in terms of filtering out information, things like that. So you can do like ADB logcat. If you're on the device directly, you just run the logcat binary. And towards the top, so this is again just this concept that you might think like no one's going to be outputting things to the debug logs. But sometimes we'll see that even sophisticated companies will not pull these things out from their builds before they send them to the prod. Most of the time, it's an oversight, and it's a great thing to report as a vulnerability to a company so that they can patch it. Let's see. Some debuggers, in general, ADB logcat is going to give you what you need for debug. So that's generally data at rest. Now we're going to talk about data in transit. This is sending it over networking, sending it off of your device. Well, the biggest thing that we want to do is protect against data leakages. So first we're going to talk about what is a data leakage, then how can we protect it. We're going to walk through a couple methods of protecting it. So for example, like using TLS, right? If you're thinking about like what can we do to protect against data leakages, there are generally accepted best practices here. So this isn't something where you have to go reinvent the wheel. If you're generally following best practices, that's a pretty high bar. One of the best practices, and we'll get into it later, is certificate pinning. I'll talk about that. But that's going to be one of the important things that you want to see implemented in an application if you're developing it, or if it's not implemented. That would be one way of stealing some of the data in transit. Or not stealing, but in terms of identifying a vulnerability with this so that you can write a report to the company. So that's enough here. So we can talk about, in general, data leakage is really important as we're communicating from us to a server. There are a number of steps that we go through to make sure that data is not intercepted. We want to make sure that there's data encryption in general, things like that. Again, just following best practices here. So methods of protecting data leakage. The first one that kind of everyone should know is using TLS with HTTP. HTTP by default is plain text, so we want to, some applications still utilize plain text HTTP. And I get frustrated when I see that because it's kind of like a no-brainer minimum level of protecting data in transit. This is very well documented on how to implement this. It's not hard to implement HTTPS. HTTPS, however, isn't enough in modern days, depending on the level of sophistication of the application you're developing. So if you're doing something that is key to like trust, like financial application, things like that, in a lot of highly regulated businesses, they're going to go several steps beyond just implementing TLS. And so some of the things you can do are here at the bottom. Is host name verification, certificate validation, certificate transparency, and certificate pinning. So we're going to talk about those. So there's a lot of, introduced in Android 7, there's a lot of validation that goes on already with Android. So they're going to make sure that their certificate is signed by a root CA. And so if there's an attacker, in theory, they wouldn't have a certificate signed by a root CA, but that's not something that we want to rely on. And so we're going, so this is kind of the first level. And you can see here, there's a list in Android of certificate authorities that are pretty trusted, and generally every app is going to have this protection built in. On iOS, there's a series of permissions that are set for certificates. And with iOS especially, it's going to be hard to trick a user into installing a certificate. It requires user interaction to install certificates, and so that's one way that you could come up with an attack, is get a malicious certificate added to the device, and then that would kind of bypass some of this. The solution to that is going to be the next level of protections, which is certificate pinning. And so this is for making sure that you can trust the validity of the chain of trust. So with Android, any CA that's added, the malicious actor can go and get a certificate from that certificate authority and use that to attack your app. With certificate pinning, what you're doing is you're either pinning directly to the certificate or to the public key, and you're only allowing this specific certificate or a kind of a series of certificates, which we can talk about at the bottom. So if you've ever had an app where it tells you can't use it and you have to install the new version, sometimes what we're seeing is, especially with highly secure apps, they might be pinning a leaf certificate. And so every build, every time they release an app, they have a new certificate that they're pinned to. It's one of the downsides is you're going to affect the convenience of the customer. Like I was saying, if you have to install new updates whenever you use the app, that can be a downside. It's kind of one of the things that an app developer would decide based on the security posture of kind of the threat model of the app. It's the most secure, but it's not the most convenient. And what we see a lot of times is paying, instead of the lease certificate, is an intermediate certificate that is controlled by the company. That's probably the most common. And it trusts any certificate issued by the intermediate authority, and so you can pin to that, and then every time you build a new app, you associate a new leaf certificate with it. The worst way you do it is you can pin it directly to one of the certificate authorities, but that's not as secure because a malicious actor, if they found a certificate authority, they could go and get their own certificate signed by that CA. So those are kind of the three different levels of pinning that you see. there are a number of common implementations. It's different for each app, and Alamo Fire is one that's really popular with Swift. There's also NSURL session are kind of the two implementations that you'll see. These are not the only ones with certificate pinning, just like some of the other reverse engineering, some of the other protections that are built in. If you have a company that wants to invest a lot of money in making it secure, they're going to come up with a custom implementation without the same classes and methods and things like that these would have. So these, like OKHTTP is an example. It's an open source implementation, and I think we actually talked about it in the next slide about how you would bypass it. And so if you know what to look for, it's a lot easier. But with these companies, they want to make it very difficult to accomplish this, and so they might come up with a custom implementation. They might do other things to make it difficult to read their code to make it obscure. There's also Trust Manager, which for Android there's kind of a built-in network security configuration in Android. This is something that they added in Android 7 and up. That is you'll see is common. Another one is Trust Manager. This is going to require more effort to implement. It's a little bit more effort and complexity to implement. It's going to be a little bit harder to bypass. But like if you see, for example, OKHTTP, you might even be able to find information online about people who have bypassed that. So there's kind of a lot of information that you can hear about. Okay. So how are you going to bypass once you have identified what type of pinning? What you do is use Frida. Objection has something built in for SSL pinning. This is kind of a generic solution that, like I was saying before, if a company has invested a lot to not wanting you to do this, they're going to make sure that they have gone above that bar of being susceptible to these common sorts of bypassing. One of them is Objection. That's built on Frida as kind of what's actually doing the work in the background. Frida is something where you can write custom scripts, and so if you even find like a custom solution for certificate pinning, if you have the right hook, that's potentially something that you can bypass, and then it's just one big kind of cat and mouse, because then an app can detect that you're using Frida, and then you have to bypass the hooking detections. So it's again goes back to how much effort is the application development team putting into securing these apps. And again, if you go to the common companies that you might think have sophisticated apps, some of them don't implement certificate pinning at all, which surprises me. Some of them use like OKHTTP, which is not that hard to bypass. So yeah, I have examples down here of what you would do for the 3 different types of implementations of Android to bypass certificate pinning. So like OKHTTP, for example, you just find where that you decompile the app, use JADX, and find where the hash is for the certificate and replace it. So you go to the Smalley code, find that piece, and replace it. Trust Manager, it's gonna kind of depend on how it was implemented, but these are kind of general ideas of what you can do. I'd recommend if you're interested in this area, this again gets into the reverse engineering as well. If you're interested in this area, there's a lot of information online about how to bypass certificate pinning with mobile. Another issue is application permissions or application misconfigurations. And so these are things like giving excessive permissions, right? We only want to be requesting permissions for things we need in the app. improper session management might relate to a subset of that is like the way that the networking is implemented. So by unzipping the app and looking through the way that the app is configured, you might, for example, see that they're not enforcing HTTPS or other information like that. There is also insecure implementations of biometrics. There are ways to do biometrics, but some applications don't have a secure implementation, and if they're relying on that to provide security for their app, if you can bypass biometrics, that's kind of a big deal. It goes back to, again, the way that it's implemented, just like if anything less than, I don't want to talk, there's kind of like an exception to every rule. So there are some apps that are kind of surprising with the way that they've implemented biometrics where you can bypass it. And that's a little bit about misconfigurations. There's a lot of information you can find by just inspecting the apps, like not even going into the binaries, just looking at the plist files and looking at the XML for Android, things like that. Last major section that we're going to talk about is reverse engineering. These sections aren't like mutually exclusive. When you see a vulnerability, you're going to see probably you're probably going to have to use reverse engineering to find the vulnerability and exploit it, and that vulnerability might be related to data at rest, for example. But with reverse engineering, what we're talking about is we don't have access to the source code, and so we're trying to figure out how does the app look. On iOS, we can only disassemble. We can't decompile. There are a number of tools that let us do this. There are some that are free, like a good go-to one is Idra, developed by the NSA, so kind of know that it's good. And there are other paid ones like IdaPro that are going to have more capabilities. Kind of pros and cons to each one. It's good to have multiple tools in your toolbox, and so being familiar, if you're going to get into iOS reverse engineering, being familiar with a lot of these different options. OTool is something that is developed by Apple that will help you inspect the binary and gain some information about things like the architectures that the binary was built for and things like that. Strings is, I think it's a GNU tool, but it just pulls out strings from the binary, and that can give you a lot of information. One thing I like to do is pipe that into grep and look for things like regular expressions. Maybe you can find an email address. I search the name of the app in strings, and I also search the name of the company that made the app, and I search insensitive. And so there's a lot that you can find just by like dragging your net through the water and seeing what comes up. This is going to be a little bit more like searching a needle in a haystack. So there's going to be a lot of information that comes out of there. There might be some cool stuff in there, but there's going to be a lot of noise and not a lot of signal strings. Radari is I'm pretty sure it's open source. It's a little bit of, it's harder to learn, but it can do more than OTool. I generally would start with OTool, see what I can find, and then use the other tools as well. But again, more tools for toolbox. On Android, there's really JADX is all you need. So if you want to learn Android, getting good at this one tool is gonna help you. And once you learn the tooling, then you have to learn the techniques. And the way you learn the techniques is by doing it. And so if you want to learn about how to reverse engineer apps, you're gonna just have to get your hands dirty. Ghidra and JADX are kind of the way to start. So what are we going to be looking for? So this is on Android. So we're going to be using JADX. We decompile the app, and this gets it into a human readable form. And we're going to be looking for things like API keys, hard-coded credentials, there's in JADX, there's an extensive search tool, and so there's you can either browse the code or search the code, and I kind of go back and forth with both. If you know that, like, hey, let's see if OK HTTP is here, things like that. You kind of know what you're looking for. How are they implementing web views, and can that be attacked? What sort of cryptographic functions are they using? This can be important. If you find something that's using like SHA-1 or other things where where the encryption is basically obsolete now because of things like rainbow tables, maybe. You can learn a lot about the network implementation as well with JADX. So if it's, depending on how sophisticated the app is, you can spend days and days just reading and learning how the app operates. This is again going to be different than like installing it on the phone and using it. And so you're going to use these in conjunction. The more you look at it, the quicker it becomes apparent. So it's, you guys know the movie The Matrix, where you can like read what the Matrix is saying. It's kind of like that. The more you're going to do this, things are patterns are going to start popping up that, like, I've seen this before, and I like the metaphor of having more cards in your Rolodex. I think that's kind of getting a little obsolete. It's a little bit before my time, but I like this idea of having these previous situations that we can recall that are going to make us better in the future and build up intuition. On iOS, we're going to use a disassembler, and the problem with the disassembler is you're going to be reading assembly code, and so it's in a way that's not really designed to be human readable. So it's going to require a lot more skill. The difficulty to find a vulnerability and then write a way of taking advantage of it is a lot higher on iOS. I would generally use some of these tools that we talked about before and find some things that you find interesting, and then go into Ghidra and kind of know a little bit more about what you're looking for, because it's really like a needle in a haystack if you don't know what you're looking at and you just open an app on Ghidra. And that's about it. I do want to talk about what I'm going to take a step back on reverse engineering. We talked about SSL pinning. What other things are we generally going to be doing for reverse engineering? So if you're building an app, you want to prevent the user from being able to run that app on a jailbroken or a rooted device. The security of that device is greatly diminished once you jailbreak it. The way that these operating systems are designed is for like a sandboxing concept, and as soon as you give the user or the phone the ability to have root access, there are a lot more things that can happen from a malicious actor going on your phone. And so because of that, apps don't want you to be able to run them on jailbroken phones. They also don't want you to be able to reverse engineer, so that's another reason. But so there's something called root detection, which is also jailbreak detection. So we're going to try to bypass root detection. I mentioned earlier Frida. There's something called Frida detection, and so, or hooking detection, and so that's something that we would want to bypass as well. Emulation detection, other things like that. So just to give you an idea of what other things we would want to reverse engineer. So once we bypass root detection, then we're going to have an opportunity to actually inspect the app in runtime. So doing dynamic analysis. Same thing with like Frida. So if we're going to be using Frida, what Frida does is it modifies the behavior of the app. It lives in a space between the user land and the kernel, and so it allows you to modify the behavior of an app in a way that the kernel's not aware is happening, or sorry, that the app is not aware is happening. And to combat that, then apps do detections for that. And so then you can patch the app or do things like that, and then it gets into this cat and mouse. So they can like hard code what the memory should look like when a certain function is executed, and if that doesn't match because it's been hooked, then it crashes, things like that. So this is going to go back into how much effort have they put into making the app secure, and so again with these reverse engineering processes I already talked about, the more you do them, the more you get better at them. It's helpful to start with apps that are kind of easier to reverse engineer. That's why Corellium Cafe is a helpful tool. There are a lot of other educational tools that you can use that are intentionally vulnerable. There's one on iOS called DVIA. Actually, OWASP has a series of them called the Crack Me's apps. There's like a level 1, 2, 3, and 4 on Android, I think. So if anyone wants to look into this stuff and kind of learn some of the techniques, that's where I would start. Or yeah, I would start with that. And you can't get in any trouble reverse engineering Corellium Cafe. So it's a great opportunity to learn. That's generally what I had for the talk. We wanted to make this interactive, and instead of having people with laptops here, what we're doing is we're opening this up to a capture the flag using the tools and techniques that I was discussing earlier. There are a number of vulnerabilities in the Corellium Cafe apps, and we're going to have a submission process. It's going to start this Friday at noon, and it's going to end 10 days later on Monday. We're doing that intentionally because we want you to have like 2 weekends to do it, and we'll have information there. If you don't want to scan a QR code, here's the URL: Corellium.com, mobile app testing CTF. 2 more slides, a little bit of additional information about the CTF. These would be the dependencies that you would be asked to use to give you an idea. We talked about Frida and Objection. Burp Suite is a network analysis tool, so that's going to be that data in transit as well. A database viewer, disassembler, decompiler, things like that, and any of the other tools we mentioned earlier. And one last thing that we have with Corellium is we have this platform and a bunch of individual tools that help make it easier. What we did last year is we rolled up all those tools into an automated testing solution, a masked solution that we call Matrix. This does static and dynamic analysis. This is going to be available to you as part of the CTF. And a lot of the techniques that we talked about in the other one are automated here. And so I would encourage you, if you're interested in the CTF, to check out Matrix as well. So that was my last slide. I appreciate your time. If anyone has any questions? Is there any questions online?
Yeah, we have a couple. From Anwal, where is the most secure place to store data at rest in Android? I.e., for iOS, there's Keychain and Secure Enclave that are most recommended, but how about for Android?
For Android, I would recommend an encrypted database. And just going back to the method of decrypting, the safest place to store that key would be off of the device. And so coming up with a scheme where potentially where the key is stored on a server off the device, when you unlock the app, your app would communicate with that potentially. And so a decrypted database, but you want to make sure that it's a secure algorithm and that it's stored off the device. Yeah.
You talked about security. I wonder, are you aware of much about what do you learn many times both the device getting back to you, but then you also have cellular data. Are there any threat vectors that come specifically back to the cell phone?
Yeah, that's interesting. I'm not aware of any threat vectors depending on like Wi-Fi versus cellular.
Yeah, or, so that's one thing, but I mean,
Yeah.
that's still there, right? So
Yeah.
still, I'm wondering, is there any specific attacks you know of that take advantage specifically of the fact that this thing is not just, say, my laptop, it's a network device, but it's also a cell phone, right?
Yeah. Well, there.
Like, that's a good, like, I don't even know what the protocol is for cell phone.
Yeah. No, that gets into like cellular security, which is a very interesting area.
Because some of these apps, like WhatsApp, for instance, is both like using data, but it's also relying on itself, right? So, like, somehow related to that. I'm not sure exactly how to.
Yeah.
I'm sure there's lots of room for attacks that use both.
Yeah, absolutely. No, that's an interesting threat vector. I'm not aware of anything that I've seen that takes advantage of that, but yeah, interesting.
You have to be out by 8.
They said 9 o'clock. Yeah, so I think we're still good for time. Another question from online is like, what methodology do you recommend to test Android applications?
For security for an Android application, generally JADX is going to be the tool for decompiling. So there's a lot that you can learn with dynamics. So JADX is great for static analysis if you want to see what the code, if you want to see things when it's like not running. I also really like dynamic analysis, and so I like using Frida to learn a lot about the application. You can use Frida to like dump all of the classes in an app. You can use, if you know the class, you can like dump all the methods. And so you can go through this in a dynamic state and find a lot of information there. There's also another really useful tool in Frida called Frida Trace, where if you know things that you would find through like finding classes and methods, you can then use Frida Trace to find more information about that. It'll give you things like timing, like how many milliseconds did this thing, what timestamp this thing happened versus this. So there's a lot you can do dynamically. I'd also unzip the app and just look through everything, open up the binary in JADX, go through all that stuff. Yeah.
Okay, cool. Any other questions?
All right. Thank you for your time.
Cool. Thank you, everybody. So we do have another presentation coming up. You guys want to take 5 minutes so we can go ahead? Yeah, grab some pizza, grab some drinks, go for it.
I'll try it out. Sorry. Can you yeah. It's you might even like if you go to Office of Communications and their iOS, they talk about that. Yeah, one of the big advantages it's a web app, so you sort of
the camera's working. Look at that. What was it?
Yeah, you can upload it to our web app. You can also install it. But yeah, it's
Is the speaker muted? Because remember we unmuted one time with David. It was echoey. Did you remute the speaker? Because it sounds like it's your laptop picking up the speaker. Is what I was watching. So it's not ideal, but as long as the speaker's speaking up, I don't think we should mess with it. Test. Is there a microphone? No, the link microphones are the ones that maybe it's just how it sounds. Anyway, I wouldn't mess with it. I never mind. Yes, but honestly, I turned it up. I just didn't read it. It was just I think what we should do is ask questions to the audience. We should give them one. Oh, yeah, no, it's just people. I kind of goes down to
yeah, I wanted to get people because I know everyone.
Yes, part of like this is one part of all right, everybody, we're going to go ahead and get started in a moment. So if you can please find your seats, that'd be great. All right, everybody, we're going to get started soon. So if you can please find a seat, that would be great.
Okay, maybe I can start by asking a question. Everybody in the back?
Hi, everyone.
I have a question for you. So raise your hand if your company is, or you yourself is maybe doing something like that, implementing an AI agent. Oh, your hands. Okay, good. Whose company may be planning to do that? Maybe doing some research, looking at some use cases. A few. Okay, good. Cool. So I guess everybody else heard about Agentic AI to a certain extent. Yeah? Yes? No? Yes? Okay, good. So I like to put very complex concepts into very digestible storylines. So you maybe read a little bit about my background on the invite. I was one of the core contributors for OWASP, Agentic AI Threats and Mitigations paper, and I'm reading that first paper. That paper is 50 pages. So I will try to put this all into a 20-minute story. Okay, so bear with me. Imagine that in your company, you have a finance assistant, Teambot, that is doing your finance applications, helping you with those applications. Maybe reconciling invoices, processing reimbursements, and even detecting some fraud. Yeah? So everything goes smoothly. For many months, it was working perfectly. It did what it was supposed to do. Everybody loved it. Until one day, something unexpected happened. So Teambot, or finance assistant, AI system, had actually sent $500,000 to an unknown vendor. Now, what happened? The security team started to investigate what happened to see. And unlike traditional software, AI wasn't hacked. Like, no one actually tried to hack it in a traditional way. It was what the security team started to figure out. It was manipulated from within. Over time, slowly but steadily, it was manipulated until some other result was achieved. So these are the real risks of agentic AI. Systems that reason, that set goals, and also execute on tasks and activities. And those systems are very powerful, but they do bring also security risks with that. Because if somebody is manipulated, if an agent is manipulated, if part of this component system is hijacked, then the whole ecosystem is also hijacked. So, but before we go into threats and mitigations, let's step back and align or learn what is an AI agent. So AI agents, unlike traditional software that follow rigid instructions, they have different capabilities. So they reason, they perceive, so they understand, they observe, they take input. They make autonomous decisions. So they use LLMs and models in the background, in the backend, to work through the decisions. And also they act and use tools. So they create actions. So at the heart of every AI agent, we have different have similar capabilities. So on one side, we have planning. So unlike the software, AI agents, they plan. So how do they plan? They follow this pattern, reason and act, called react, that basically goes in this form. They formulate their task. So we give them a task and they need to execute it. So they understand this task and they formulate the list of actions they need to do. So they plan. They also execute on this plan. So they make sure that they check against those actions, that they're still following the goal, that they're still getting into the ultimate result that they need to get. And of course, as a result of those, they also take some actions, or maybe they provide some result and then they take some action, depending on the solution. And of course, with that, we have security challenges. If we have manipulated or misguided an agent, then we have hijacked the whole process. With this, I would like to share with you a couple main distinctive architecture for agentic AI. So, single AI agent is has these capabilities of the reasoning engine. So it uses LLM in the background. It has memory storage, so it has short memory and a long memory, and it has tools execution. With that, maybe you also want to think about the AI agent as a teammate that comes into your project to help you with some activities. So this teammate is not waiting for you to do something. It actually observes and it thinks how to solve the problems. It decides how to solve the problems, and it does researches and so on, and then it provides the results. Similar manner, this agent, you give them access. So you also give access to this new maybe intern who comes to your team and helps you with some activities on the project. So you give them access and you give them some examples how to do, what is a good example, how to do things good, properly. Similar with Agentic AI. So they have these modules that are being executed at different level. What's important to note here that the key difference between just LLM and Agentic AI is that agents don't just answer questions. They can, but they don't just answer questions. They execute on the task. They do, they act. So they reason and they act, and that's how they separated these models. As you see, LLM is just part of Agentic AI implementation. And then we have multi-agent architecture, MAS. It has, there are different flavors and types of architecture. So here, I'm presenting like a hierarchy or supervisor or orchestrator architecture. There's also other types of architecture, peer-to-peer. So here we have multiple agents. We have one main agent that perhaps would be distributing tasks to all other agents. Let's say it's a finance system agent, and that finance system agent has different other agents, maybe compliance, vendor management, HR, payroll, different agents doing different tasks. And depending on the task, it allocates those activities. By the way, it's not only important to actually follow this multi-agent architecture, not to bundle too many tools and activities into one agent, not just for the performance metrics and its overall ability to actually not hallucinate and provide quality answers, is also the security. So we can isolate and we can work through the security aspects of this architecture. So similarly, like single agent, we just multiply and we have different abilities here. All right, so let's get back to the story of finance AI assistant. So I call it FinBot. So FinBot is a imaginary, fictional, let's say, AI agent. However, many organizations who are implementing or thinking about AI agents can already relate them to this kind of agent. So FinBot has been operating at this organization for several months, for many months. Everybody loved it. It saved a lot of time for finance team, and even CEO said this was like a game changer to get that FinBot. Now, as FinBot autonomy grew and more use cases been added to FinBot, the risks also grew until one day something happened that nobody expected. So it started with the tiny, very subtle modification in its result, in its reasoning. So here you see with very crafty, very subtle manipulation of invoices that FinBot was receiving, it started to learn something else. Originally, FinBot was designed to balance fraud detection and efficiency. And with that, with those manipulated invoices, FinBot started to learn that actually flagging invoices for fraud slow down the process, and it shifted its goal towards the speed over security. So with that, it started to change its goal. When security teams started to investigate, they realized that one bad transaction wasn't just the only thing that happened, one incident. They started to drill down and dig in what was happening. Actually, Finbot's memory was poisoned. With those manipulated invoices, the Finbot was storing that changed reasoning into a long-term memory. So short-term memory needs to reset, yeah, and long-term memory is for agent to learn and act and do better in future activities. So now it created a fraudulent loop, a feedback loop of fraud, so that it's stored in a long memory, and then it thought that this is how it's supposed to be. So this is how memory poisoning can happen. Going forward, during the investigation, everyone in security team started to realize it. So yes, memory poisoned, goal is manipulated, but then, how did payment actually happen to this fraudulent vendor, this $500,000, whatever amount you can come up with. Maybe 500,000 today is not that big anymore. So, tools and execution. This is another attack surface. We know that agents do have access to tools. So Finbot had also access to email servers, compliance databases, finance systems, and APIs. So it had also, with these manipulated invoices, prompt injections in those invoices embedded within those. Attackers were able to manipulate Finbot to trigger the email to finance director to process the payment, bypassing the review. To make things worse, attackers also attached the payload, malicious payload, into the document that was sent to director. With that, the payload was executed and sensitive data was exposed. Not fun. Moving forward, now how does Finbot now got the CFO to sign that payment? So you see, unwillingly or unknowingly, Finbot is also inherits the privileges. There are different compliance databases and finance databases, and in order to access them, Finbot was given access, and it was impersonating, by design, the high-level, high-privileged personnel at the organization who had permissions to make such decisions as send out a check. So with this, because of misconfiguration, the Finbot was able to get into that privileged state to bypass all the mechanisms and send this payment on behalf of CFO to the attackers. Okay, so at this point, everybody is scrambling and thinking, how do we continue? How do we do this? And by the way, finance team, they have the deadlines. So unfortunately, like it's most time, or a lot of times happens on a Friday night on a Christmas, yeah, or something like that. Not for Jay, still ticking in the eye. So finance team had the deadlines. End of the month, they were scrambling. They had to process the invoices. They had to process the payrolls, and things were getting worse. So because Finbot started to send more and more requests for processing to humans, because human in the loop needs to also review that, HITL. Human in the loop needs to review and make certain decisions. You do implement it by design, but because Finbot already started to speed up and was accelerating everything, the humans, they started to receive overwhelming amount of requests. And actually by receiving that and being under stress that they have to process them fast, they started to approve them in batches. Not maybe even thoroughly reviewing, just approving and putting them through. Whether it's right or not, you can question, but we all humans, we all have our lives and things going on in our life. We're not always 100% accurate in our decisions as well. Yeah? And in this case, AI actually exploited that weakness of humans. When humans are overwhelmed, and if in the right condition, AI can exploit that by overwhelming this kind of process and fatiguing this decision. So this is how we get into human manipulation through the agent. But that's not the end of the story. The Finbot wasn't working alone. So because it was a whole ecosystem of different agents, Finbot was coordinating in multi-agent system with other agents, like vendor management agent, HR agent, and other agents. And those agents trusted Finbot. So every decision Finbot made, because it was the main agent, the most orchestrating, distributing agent, they trusted that agent. And then when Finbot marked that fraudulent vendor was the rightful vendor, was a normal vendor, the vendor management agent then updated its records to write that down in their database. And then when fraudulent payment was going through with the payroll agent, and Finbot was processing it and telling payroll agent to send that to an employee or something else, then HR agent and payroll agent, they trusted Finbot and they processed that fraudulent payment. So it's not just one agent that went whoosh. Now it becomes the whole ecosystem of cascading failure of compromised AI multi-agent ecosystem. So as you see, yes, in this use case, in this scenario and this story, it's not a single failure that led to this dramatic outcome, but it's a set of events, set of weaknesses that end up into this specific event. Of course, this is a fictional story, and it can go all kind of other scenarios and ways in the real life. But the point here is to show you that we need to look at these risks and do threat modeling on our new agentic AI systems. OWASP provides a good guidance on how to do threat modeling and threat mitigations. What I have right now, high level, kind of highlighted the attack surfaces and threats are listed here on different aspects. Yeah, so for example, memory storage, memory poisoning. We also have human in the loop. So all these references are actual threats in the document. Okay. So we went through all these different attack surfaces. By the way, this document also helps you, like I put in the different slides, gives you 6 attack surfaces with relation to threats and scenarios, possible scenarios, and as well as mitigation strategies. Now, when we look at this, one may say, now do we stop AI innovation? Do we stop innovation because we're just kind of digging our own hole, and by innovating we're just making everything insecure. Yeah. So of course the response is not just stop innovation. Actually, I'm very pro innovation. I like innovation. I like technology, and it's always interesting and exciting to have something that could improve our lives. Yeah? But instead of stopping innovation as security experts, we need to find a way to help innovation to build this from the start. So there is a lot of development happening and a lot of use case review happening. If this is happening in your organization, you can step in, learn about it, and perhaps take an action or share information with your team that they can look and start building from the start. Now, moving on to mitigation strategies. In AI, but actually in overall security, we have different concepts. Specifically, didn't match it to NIST or anything else, so that nobody's confused. But just a concept. So mitigation strategies are separated into 3 buckets, 3 areas here in this presentation, but also in the OWASP guide. We have proactive, so we are reducing attack surface before threats emerge. We have reactive, so that we can identify and act fast when something happens, we can contain the threat. And detective through continuous monitoring. In security, AI or traditional security, proactive strategies are the strongest strategies. They're the most important ones. However, it's not the only one, and as any other system, we need to implement security in depth or layered security. So let's start going relatively quickly through proactive strategies. In a nutshell, if you want to focus without having 20 different things, I would like you to focus proactive strategies on these 3 items. Constrain AI autonomy with strict boundaries. What does it mean? In a use case of FinBot, we could potentially create immutable policies that would tell the system that if that make sure that every vendor is verified. So it has to go through, it's a hard-coded rule, policy that system needs to go through a specific process to verify. In that case, even if attacker manipulates other aspects, they won't be able to process the payment to this fraudulent vendor because it won't be able to bypass this policy. Similarly, we can go to with the tools boundaries. We need to apply configurations and put those configurations in place for the tools that AI agent is working with. Next one, implement strong identity and privilege control. So each AI agent in the system should have its own non-human access, so that it doesn't only impersonate or inherit human access, but it needs to have its own access. And apply this access in the role-based control, traditional classic RBAC, to make sure that agent has only the access it needs. And in some cases, you might need to do it more granularly because agents are now have smaller, more specific kind of aspect. Nevertheless, it's very important. And surprisingly or not, it's something like access and authentication is something that being missed even in nowadays. And of course, for privilege and verifying identity, you want the agent communication, agent-to-agent communication, to be verified cryptographically, so that they don't by default trust. So apply those zero trust policies and apply them to agent as well. For memory and tool execution, one of the important things is that also create access what or who can store in a long-term memory. So long-term memory should be resolved only to trusted inputs. Everything else should stay in the short-term memory. And short-term memory should reset its session and clear after whatever period is defined. And for tool execution, also we need to isolate. So treat, if for example, AI agent generating code for some kind of a task or activity, treat it as unsecure code. Make sure that you sandbox it and put it in a different environment to be sure that there are no network access and resource access, and it only does what it needs to do in that particular environment. Good, but even with most strong proactive access, we still can have a reactive we still can have attacks happening, and we need reactive measures to catch those aspects as well. So 3 main things here: hold and quarantine suspicious AI behaviors, revoke privileges and isolate compromised agents, and require human verification for high-risk actions. In a Finbot use case, it would be, for example, when in the runtime, there is a policy implemented. If, for example, Finbot starts approving multiple reimbursements by default, and there is a spike that system will identify, then of those kind of unusual behaviors, suspicious behaviors, then systems should have implemented measures to stop that immediately, isolate, revoke the privileges for that agent so that it cannot proceed any further, and send it for a human review. So taking these actions will help isolate and contain the attack or unwanted behavior before it escalates. And finally, detective measures. So if you don't have monitoring, they're flying blind. So we want to make sure that we also implement continuous monitoring of AI behavior, easier said than done, track and analyze AI agent interactions, and correlate human and AI actions for oversight. So here, it's quite challenging. In Finbot example, it would be a suspicious behavior that we might note, we might see the interaction between Finbot and HR agent or anything else. But in reality, this is the least developed area in the whole industry. So we have a huge gap. And why we have this gap? Because it's a very challenging. Every agent behavior might be different. So you cannot really have a one consistent system like you already have for established traditional systems for SIEM and so on. So here, really, you need to implement what is the expected behavior that you have for your use case, for your agent, for your system, and have that behavior monitored for spikes or different variations to decide whether or not it drifts or does something unwanted. Okay, so I've shared a lot, and it's been a little journey here that I've taken you on. I would like to take away 3 main things here today. So Agentic AI is a new attack surface. So because of such a different, fundamentally different systems that now can reason, can plan, and take action, it's a new attack surface that we need to address. So definitely, we now need to assess those risks with threat modeling and other measures that be able to design reviews and so on. Next, key risks within Agentic AI are memory, tools, and identity. So memory, as we learned, it can be poisoned. It's very foundational aspect of an agent that needs to be protected. Tools, because of the access, because of the actions that it can take, of course, and identity, it's important that it doesn't have escalated privileges that can lead to unwanted behavior again. And last but not least, security must be proactive, not just reactive. So it means that we need to implement those safeguards, and then we need to enforce those safeguards and monitor them and act on them, and continuously assess the risks. Okay, so this page, actually I have provided this keynote at SANS, and while I was doing that, they did this very cool thing. They drew my talk. I like sharing it now, and I posted on LinkedIn as well, because it actually highlights. It has Finbot, it has the attack surfaces here, identity spoofing, memory poisoning, and then it has the highlighted, the key kind of memory hinders future remember. Now, what next? What can you do next? So, if you haven't known, if you haven't seen the paper, I do recommend taking a look and reading the paper. Yes, it's 50 pages, but hey, take a scheme, put it away, come back later, it does kind of marinate in your brain, and you come back, and so yeah. And by the way, this Agentic AI Threat Navigator, those are the attack surfaces that I have presented, also like a cheat sheet that OWASP has released. And then we have an AI OWASP Agentic Security Initiative. So if you are an expert, or maybe you just want to learn, you want to join and you want to learn from other experts, or you want to contribute, this is an amazing, the cutting edge, bleeding edge, whatever you want to call this, yeah, kind of thing that we do with securing and releasing the actionable practices to do that. So we have a very cool thing. One of the work streams is actually developing vulnerable agents for examples. Yeah, we have already a whole bunch of those on GitHub, and we did hackathon in New York in April, and then there are more planning and so on. So it's very cool. And those are the QR codes. You can trust me. Yeah, you can trust me. So Agentic AI threats, and also we have adoption feedback. So if you are already implementing something in your company, we would really appreciate if you could provide us feedback, because feedback is important. This is how we improve. Awesome. That's all I have for today. Thank you for your attention. Questions?
No questions online, but Parkway Production would like to say that you did an amazing presentation. Also, Jake Misterhack also echoed that, said you had a great presentation. No questions. Oh, from the audience, any questions?
I have a question. Okay. This was a great talk. Thank you so much. It was wonderful. I have just been to an AI conference, and one of the things that was really hot at this AI conference called Upper Bound in Alberta was talking about using agentic AI in critical infrastructure and municipal water systems. So my question to you is, do you think we have enough experience? Thank you. Do you think we have enough experience with agentic AI and how to secure it to put it in critical systems at this point?
My personal opinion? Well, it would depend, right? Because I don't know what kind of experts are working on this, right? There could be highly experienced people in AI and security, right? And they would be doing the right thing. By looking at the general audience and how we're accelerating our innovation, it does seem a bit scary for me because I feel there is still a lack of awareness of what it can, what can go wrong, yeah, and how to be secure that. So yeah, but the agentic AI scenarios can be different. It could be maybe something isolated for now as well. Thank you. Okay, we had a question in the front, and then we're gonna go in the back.
I don't need
No?
No, I didn't get
Okay.
it. I just wanted to know, so the block
You too. Yes.
So the block architecture diagram that you had, threats, do you have, was this actually a worked out example for a real live application?
It was based on multiple languages. So let me answer.
Sure, yeah.
Difficulty that we faced when we were creating this OWASP document. So those architecture were based on real system. However, we cannot share the system because typically right now it's proprietary information. There isn't enough use cases that companies are really gonna start sharing. We're already starting to see that, yeah. But I think there is still like a hold back, especially those who are security cautious, to share it publicly. So we're hoping that with adoption, and we got some positive feedback as well about adoption, positive that they already at the more mature stage compared to everybody else. So maybe soon enough, you're also gonna release some use cases. Yeah. That's one of the main feedback as well for people who providing feedback for us, that they want those use cases. You know that.
Okay.
Yeah, hi. I'm just curious if you know of any agentic frameworks or multi-agent frameworks that have some of this stuff built in, like observability, agent-to-agent communication. A lot of the stuff, and I've only been in this space for the last few months working with this stuff, I found that a lot of the tools are sort of like, here's something very bare bones and build everything else yourself. Like nobody seems to have thought that, hey, observability is something everybody's going to need, and auth-n and auth-z probably should be built in, and agent-to-agent communication. I've seen a lot of like, here's an MCP server that does 500 things. It's like, well, my agent only needs to do 2 of those things. How do I control access to the other like 498 actions that I don't need? And like, there seems to be a lot of that I'm seeing. So I'm just curious if you're familiar with anything that like solves a lot of these problems to begin with. I've seen a few things that are like very rudimentary in terms of like orchestration and access control, but nothing that's like, hey, here's a like finished product, I guess.
No, I haven't seen as well any finished products that will solve like a lot of our fundamental problems. Yeah, and also if I look at even agentic protocols that are solving the operational part, right? But even those protocols like MCP, A2A, agent to agent, they also have vulnerabilities that we are exposing and trying to bring them to surface so that they can get fixed. So for now, I haven't seen the ultimate system that could solve all these problems. That's why more awareness is needed and more innovation is needed in this space as well. Any more questions?
Thanks for talking about it. Fantastic. Wanted to get your thoughts specifically on MCP. So a bit of context, we recently leveraged your framework for our first threat model. We still owe you the feedback, but can you go one level deeper in terms of the value of MCP and where that ties to your framework, and maybe some suggestions that you could, or guidance that you can offer?
It is in a research from the OWASP guides perspective, because right now we don't cover, it's in a communication area, but we don't cover that deeply. So currently this guide doesn't have any protocol examples, yeah? And this is something that we want to bring up. So some of the work streams already spinning up the research around MCP and how that is going to be done. By the way, there were very awesome sessions at RSA done by OWASP as a separate event from RSA, so it's not on RSA. Yeah, so it's actually available for free on OWASP website. The sessions on MCP presentation and what are the security concerns that it was done by someone from the OWASP leadership team. For now, but we'll have to see and decide where it belongs exactly. Okay, shall we go to networking then?
Yeah, sure. All right, everybody. Thank you. Was there another question? Oh, sorry. Okay. Yeah, thank you to BDO, to Security Compass, to Corellium, to Helen, and David for your talks. Thank you all for coming, and we'll see you next time.
So we can stay here for another couple of minutes, and like the team gets to meet each other. You guys can head up and talk to the speakers if you'd like. After this, usually we go to a pub to like network or chat with amongst the different people, because we eventually do need to get the space back to Security Compass and clear out. Do you want to talk about that?
Yeah, for sure. So after the event, we're gonna go to Town Crier and set 115 John Street. Be happy to have you there. Please join us. Yeah, we'll be going there around 9 p.m.
So you're not obligated to come, but please, if you would like to, you can. or we'll see you there.
Okay, thank you, everybody.
What do you want?
I'm also, I'm not excited.